Okay, hi, Shubin. This is Vincent here. So I would like to take this opportunity to present my project for DLSD. The title is Identification of a Playmobil Figurine. Let me just quickly put this in presentation mode. So I have about 6 agenda. Talk about project objectives, data collection and pre-processing process. What are the architecture I've used to compare in terms of best outcome for the prediction? Summary and findings, and what are the key findings in terms of doing the fine-tune of both models. Deployment into integration into both web and Android platform. Kind of do both to look at the differences. Also, finally, I have the web link submitted in the presentation. So just go right in. So the system will be able to detect and sort out 4 categories of Playmobil figurine, namely the man, woman, boy, and girl. So if you um, look at the images here, so you have a man, a boy, a girl, a man, and then a woman. So distinctly, they are different. Let me get through the data first. So the data will be collected from 7 figurines. So what do I mean by 7 figurines? So let's just take a look at the 7 figurines. One will be the full body image. If you look at this, is 1, 2, 3. So 3 image of a full body Playmobil, and up to 4 categories: boy, woman, man, and girl. And then the other 4 images or videos will be the head, just a head alone. So if you look at boy, will be 1, 2, 3, and then 4, 5, 6, 7. So altogether 7 different figurines, different forms in terms of the video shot, and multiply that by 4 categories. That will give us about 28 videos. Those are the preparations for the images. So the test set, I have again different figurines for the 4 categories. So I'll go through that later. Okay, let's just get back to, okay. So 4 categories, 7 times approximately 150 images frame, which will be collected from each video file. 7 times 150 times 4, and after augmentation, I get about 16.8K of images before cleansing. I tried both models, mobile net and Inception, to see which is the best outcome. And the attributes that I felt were critical after the whole process were actually the features of the eyes, the body, the height, hair, and face. So critically, the face seems to be an important feature to distinguish between the different categories. I also had a chance to deploy into web and mobile applications. Most of the reference I had was mostly from the notes from Temasek Poly, and then some of the other websites listed here. So what are the industry application? I think we can use it for sorting out of the figurines within a manufacturing and production process. At the same time, we can use it for some game experience, be it a development of interactive games for any ages. Okay, so that's the summary. So let's just get down to data collection and pre-processing. So video files of each figurine captured for about 5 seconds. Let me just quickly run this for you to see. It's about 5 seconds video. That's how I shot the image, and then that's for the full body, and this is for the head itself. Okay, so essentially about 5 seconds each for the video captured. Extracted frames from each video file is about 150 images, and then again 4 categories, 7 video files, full body as I shown you just now in the train set, 3 figurines, and then heads only consists of 4 other figurines, just the head alone. Altogether, 1 category, 7 video files. So the data cleaning process after the extraction of the picture frames. Just quickly go through that example of how I clean the data will be. For example, if you have image that was cut into half, and those are not clearly defined within the whole picture, so I took those out. And likewise, pictures like this with overlapping images where the colors are overlapped and the two different figures are overlapping in terms of the pictures. I eliminated those. So cleaning like this to make sure the pictures are full are done before the augmentation process. Okay, so let's just get back to this one. Data cleaning process done. So the pictures frames are also augmented vertical flips, horizontal flips, rotation, and before splitting into training and test set. Again, the model training following the augmentation. And in fact, at the end of the whole process, the available images that were used for training was about 15.4K. So that's the collection process. Let me just get down to the next page. Okay, let's take a look at the program script within the core lab before coming back to this presentation. So the program script were mostly extracted from the teaching notes, and of course I added a couple of things. So let's just quickly dive into it. I have actually uploaded the image quantize and the retrain py file, and also mounted the drive to save time. So again, this was basically deleting the previous frame. Now coming down to this particular video extraction file for each of frame, essentially we uploaded each of the categories for man, woman, girl, and boy, 7 video files each. So 7 times 4, 28 video files. Extracted the images during this whole process about 28 times. After that, download the files, and then we save the file into the hard drive for pre-processing. Deleted those that are not relevant. After that, we are actually ready for augmentation. And the augmentation, I added in two points here because I needed to repeat a couple of steps. So I needed to delete the previous video files, images. So again, this whole process run through all the images frame that has been developed to augment vertical, horizontal flip, and also the rotation down to this process. So after that, of course, the drive is mounted here. Following that, we are actually kind of ready to do the training. Again, these are basically unzipping the files into the relevant folder, which has already been done. The test is here, you can see, and then the training files are all uploaded here with the augmented images. So after unzipping the whole process, we go down to install and downgrade the TensorFlow to 1.12.0 to run the program. So this has been done earlier. Now coming down to training of the model, I actually of course, started with 10 and then increased to all the way to 100, and that's for mobile. Then at the same time, I actually started with inception. Again, it was 10 and then subsequently increased up to 400. So two models are listed here, but I ran through both models, eventually found the best fit for the prediction. Everything is logged into my folder, which under mobilenet.log, and the other one is under inception. So let's just quickly go down to the model testing. So after the model is being ran, I had those files generated in the logs folder. So let's do a test right now on the test file for this particular image. Let's run here, and I run under MobileNet. Okay, so again, this is a movement test. This is a movement image of a Playmobil. We run the test. Okay, let's give it a few more seconds. Okay, so we managed to get pretty good prediction of 98% for the women. Again, inception was the same way that I did the test. Of course, I'm not going to show it now. Going down to the deployment, I also had the optimized model and also the quantized model. Again, both are for deployment into web and also Android models. So this has been ran as well. And again, let's just test out this image, which is a boy here, and just test out on the optimized graph that we had. Okay. So again, boy came out to be pretty good, 99%. And of course, the quantized model has been ran too. And then we can test out using this image alpha man test 1. And basically the files, even though it's been shrank in size, but the outcome is still pretty good. So I think that's I have for the Colab program script. Let's get back to the presentation. So we are back here to the next page, which is the results and the fine tuning. So how I started the whole program and try and error was we started with a full body, which is this called a full body figurine. Started with this inception model actually, and then the first time when I ran it, it was just one figure, 4 categories, and the score was average 30%, which is not good, especially for the low steps. For all the prediction, which was also inconsistent in terms of the outcome, whether it's boy, girl, or man or woman. I increased the number of figures to 3, so the score went up a bit, 50% there, but for less than 100 steps. So when I increased to 400 steps, the prediction became more consistent, but again, the score was very inconsistent, and it took a long time to run, the 400 steps for the full body. I actually progressed to try to see if maybe the head was an important element, and we needed to make sure that the head are more clearly defined rather than the body. So I put in the head using inception. Again, prediction was about 30 to 40%, but it's just the head only, so again, not as good. So I went on and moved into MobileNet and tracked MobileNet. So with the full body figure, just 3 figures, well, there were some promising results where boy, was 50% and man was 100% in terms of prediction rate. And the steps were only 40, so it's a much faster kind of program to run. And then when I get to the main part of it, including the 7 figures altogether, full figure and the head, the results were significantly better. So score average 50 to 90, and the steps were at 40. So when I increase the steps to 100, actually the score of 90% has always been achieved for the equalizer. So in summary, I think tuning the steps, at the same time adding more data, does improve the score accuracy. Of course, MobileNet seems to be the one delivering the results rather than Inception. So that's the fine-tune part that I did. Let's just get down to the summary. So for summary, clearly MobileNet appears to work better for the project, even at those steps, 10 to 40 range. Best results at 100, of course, steps, and total images, this was 15 to 4K. If you just have a look at the accuracy here, you can tell that, in fact, if you're happy with 95, we can stop at step 70. Cross entropy is almost flat line now, no longer increasing. So, but of course, we did all the way to 100. So that's something that we did. The bottlenecks at 15.4 can be shown here. So Inception works fairly for steps 140, but not lower. Both architecture yield inconsistent category prediction at low step and score accuracy. So additional training data, not in similar form example head only data, greatly increased consistency in outcome on the category and also the score percentage. No discernible processing time difference using both .pb files, optimized or retrained graph for the web deployment. Full body images appear to introduce more noise compared to the head-only figurines due to the various differing body features. That's an example, right? Clothes and color, we have no relevance to the outcome, whether it's a man, woman, girl, or boy. The clothes and the color of the clothes they wear has probably no play in terms of the prediction. So the head is a critical element. So in summary, the mobile net is recommended as it provides higher score percentage and better prediction results, coupled with a shorter processing time than inception. So that's I have for this summary. Let's coming down to the last part, which is deployment. I want to show you a video of both the web-based and the Android deployment. So let's just proceed with both videos for now. Okay, this is the web recording, web deployment model for the Playmobil on YouTube. Let's just have a look while I try to explain through. So we launched the Anaconda Navigator, open the terminal, and then basically go to directory and launch the file, which is Playmobil identification.py to get the web address. So I think this web address, this web deployment was actually much easier than the Android one, because the Android Studio appears to have more errors, and trying to solve the error took more time. So the web one was much more seamless to deploy. So going to the website, I did some change on the header and also the naming. So browse, I loaded an image. Therefore, I see the boy at 89%. And then you have a girl test open up, and you upload it, and you see the result for 96%. Just two more, the man. Okay, it's again 99%, the men, and then the women comes. Yeah, so there we have it for the one on the web deployment. Hopefully this continues with the Android. Okay, so the Android deployment model is here. You can see, so we will launch the Android Studio. I do a shortcut, so I did the Android Studio, do the virtual image. Okay, so you see it's running, and then the prediction, putting on the image onto the camera. I can see my hand at the top to do the live prediction using the notebook camera on the virtual mobile device. So you have a boy, just now was a woman, and now a man. So again, like I say, I went through several iterations to get this running, because there were a lot of errors, and we tried to solve it on a GitHub and a YouTube information, download, upload, and then reinstall, and it does work eventually. So now it's quite stable in terms of the application when I ran it for this particular application. So there you have it in terms of the deployment for Android and also for web. Okay, I think the rest are quite the same. So let's just pause here, and then we'll get back to the last part of the presentation. Okay, we finished through the deployment. So let me just end up with the last part, which is all the folders. So I actually captured some of the screenshot here. You can see on the PowerPoint as well here. And then all the files are included, or the location of the files are included within the PowerPoint. You can click on the link on the Google Drive, and also the YouTube version. So I think, yeah, that's all I have. And thank you so much for your help and support over the last 3 months. It's been great. Thank you.